Uh,
All right, well, it's not. Oh. Okay. So good morning. We're sort of light on attendance today because of sports travel and such, but we'll go ahead and start. So you guys gave me homework last time, which I've now graded. So let me just remind you of a few things, since this is the first time I'll hand you paper homework back. Morning. Paper homework, like WebAssign, you have multiple tries. WebAssign, you can try until you get it right. The same thing is true of paper homework. So when I give this back to you, there were 4 questions. Each one had 10 points, graded out of 10, because that's how most exam questions are, so mostly out of 10. And whatever score you get on here, what I'm telling you is, if you turn this exact same thing on an exam, that's what score you would get. That's what's being communicated to you. If you got less than a 10 out of 10, then I leave some feedback, like what you should correct. So what you should do is, if there's a problem on which you lost points, you take the feedback I gave you, you rework the problem on a separate sheet of paper, and then give me back the original sheet with the reworked problem. So on this one here, covering up the name, let's see. So this one here lost a couple points. That was the only one that lost a couple points. So this person, if they wanted these 2 points back, would redo this problem on a separate sheet of paper using whatever feedback I wrote here. You give it back to me sometime before the next exam, and if it's correct now, I give you your full points back. And so, of course, you should do this not only because you can get points back, but also it's a learning tool. And in a class like this, oftentimes people are very nervous about exams with good reason, right? Many of you perhaps haven't taken an exam with math on it in a long time. So I want you to be as comfortable as possible and as prepared as possible when I give you an exam. When I give you an exam, I'm not going to try to trick you. I'm going to ask you what I asked you in the homework. So if you have stuff corrected, then hopefully that means you just sort of like on autopilot on some sense, succeed on an exam. So keep all that in mind. Any questions on the homework or anything from last time, from last class bothering you? All right, so let's dive into section 11.2 today. So we're still working our way through a financial math unit. We've talked about simple interest and what it is. The other kind of interest is compound interest. So that's what we're moving on to now. And with both concepts in hand, we'll be prepared to talk about how loans officially work, how credit cards work, how investing works, all these things work after section 11.2. Okay, so the point of today is to introduce the concept of compound interest, which in contrast to simple interest, describes a structure where the amount of money you make, the amount of interest you have to pay, whatever the story is, depends on not only the initial principal, but depends on stuff that's happened after that. So there's like this process has a memory now. And I sort of like this quote. It's sort of fool's gold, right? Because we can't all be Warren Buffett. But if you don't know who Warren Buffett is, he's worth like $1 trillion. Okay, so he's super rich. And he says this: I'm rich because I live in the US, I got lucky, and because of compound interest. So we're going to learn today how to make trillions of dollars, I guess. Okay, so here's what you should be able to do by the end of today. Be able to calculate the interest amount, the amount you have in the future, or given a future amount, the principal amount on an investment or whatever sort of structure we're using that uses compound interest. And we're going to apply this specifically to inflation, which is, as of right now, a pretty hot topic, right? Inflation rate's pretty high now relative to a couple of years ago. So that's what we're going to do today. Okay, so compound interest. As I said already, interest calculated not only on the original principal, but also remembers interest you have previously earned, or in the context of a loan, a balance that's been knocked down. That's what we saw last time. So in other words, compound interest just means I remember what happened before, or I remember what happened since the initial investment or since the initial loan was taken out. So that's sort of the high level definition. So to show you concretely how it works, let's work through an example. So suppose you invest $1,200 in an account, So I try to leave these things very vague. This account could be made up of mutual funds like stocks and bonds, which we'll talk about later. This account could be a savings account from the 1970s when you could get a 2.6% interest rate, so on. Anyway, so some sort of investment vehicle where you get 2.6% interest, and now you get interest payments each month. So you don't have to wait for the full life of this investment. Just each month you get interest. So the question is, how much money is in the account after 2 months? So to answer this, we're going to do something very similar to what we did last time with loans. And I'm very rusty on Zoom, but I'm going to try to make sure this is visible in this recording. Okay. I'm going to aim like this. Okay. So example 1, how much money is in the account after 2 months? So let me ask you, how much money, or how would you find how much money is there after 1 month? Because they're going to make monthly payments to you, right? So forget about 2 months. After 1 month, how do you think you'd figure out how much interest you get? Yeah.
You would multiply 1,200 by 0.026 and then add that number to 1,200.
Okay, so you're very close. What you're basically saying is use this formula. Is that right?
Yeah.
Yeah, so here's the interest formula. And again, let me make sure my Zoom is oriented properly. Okay. And so then what I heard you say, and maybe I didn't hear everything, you said, well, I got $1,200 invested, right? 2.6% interest. And you said something in I couldn't quite hear.
Is it 1 over 12?
Yeah, so in this case, only 1 month has gone by. So I think you initially left it off, which is all right. So if you put a 1 here, it's like they're paying you a year's worth of interest or something, which now is bad for them, right? So last time with the loan stuff, if we messed up this time amount, it was bad for you. In this case, it'd be bad for them because this is your investment. Anyway, here's how much interest they'll pay you. So $1,200 invested at this interest rate for a single month. And then, I mean, I don't know what that is. As always, if you have a calculator and you have it before me, you can shout it out, but I'll just get it on here. 1,200, 2.6% divided by 12. Okay, so you're not rich yet. They're going to give you $2.60. But concretely, what that means is end of month 1, your account has grown. So you used to have $1,200. Now you have $1,202.60. Let me make sure my Zoom is oriented. Sorry, somebody's, is that my phone? Somebody's like podcast playing or something? Or am I imagining things? Oh, right. Oh, stop. Anyway. So anyway, at the end of month 1, you've made $2.60 in profit and interest. So now to answer the question at hand, how much money do you have after month 2? What do you think you'll do? I'm sorry, say again. You might think that, but if you do that, so you guys got to be careful. There's no double counting. So if there's like double dipping, it could either really hurt you or really hurt the other person. In this case, they wouldn't accept it, and it might be illegal. So you think you do that, but you actually, since they've already paid you for 1 month of interest, they can't then pay you for 2 more months in total on top of that. That's like a total of 3 months. Yeah.
You use the total amount at the end of the month to pass the principal.
Okay, yeah. So in a compound interest situation, we remember what happened. So now we have this much money. So they're going to pay us interest on this now. And again, very close to what you said, Leslie, but this month was already banked. So they're going to pay you interest for 1 month off of this now. So they're going to do this. Yeah, let me make sure this is oriented. They're going to say the amount of interest we'll pay you this month is based on the amount you have now, which is 12,260, but nothing else changes. 2.6%. Now here's the next month. So it's actually very similar to what we did last time with loans. It's just now it's working in your favor. This is an investment. So instead of like the bank keeping an interest payment every time, pocketing it, right, while your balance goes down. Here, the amount of interest going up helps you as you get more and more money based on more and more money in your account. And so I don't know what that is. It's going to be slightly more than $2.60. So again, if you have it, you can shout it out. 261. Ah, so you know, not a lot more, but now your interest check is slightly bigger. And so at the end of month 2, okay, so at the end of month 1, you had 1202.60. Now they give you an extra $2.61. So what is that? 1205. 21. All right, very dangerous to do arithmetic. It's early in the morning, right? But we handled that. All right, anyway, so here's the answer to that question. So if you want to analyze a situation like this, you're basically just using the simple interest formula over and over and over again, like we did last time with loans. It's just now every time you move to the next step, you're updating your principal amount because you have more money that they're giving you more interest on. Okay, so that's how compound interest works. There's a memory there. So now let me go back. Again, I'm rusty on shuffling Zoom, but I think, okay, so this is shared now. Okay, so in this example here, we figured out how much money we have at the end of month 1. Or sorry, month 2. Well, what if I want to know 2 years later how much money's in there? All right, we've done 2 months. So what would you do if this is all I've shown you? What would you do to answer that question? 2 years from now, how much money do you have? Well, forget about 2 years. What if I said, okay, at the end of month 3, how much money do you have? What would you do? Yeah. Never mind. Oh, you backed away so quickly. I'm just looking for ideas. Doesn't matter if it's right or wrong.
Instead of doing the fraction, like instead of whatever it's called.
Oh, okay, yeah. So if you did that, you're gonna run into the same kind of almost legality issue with Leslie, where like they've already paid you interest on 2 months. So now if you change the fraction to 3, they're giving you like 5 months of interest over only 3 months of time. So that's actually not allowable. That you're, in this case, you're double dipping or triple dipping or something. So notice this first interest payment here, interest rate, time stayed the same, interest rate, time stayed the same. So as you move through the process, those stay the same every time. Otherwise, you're double dipping at time. What changes though is the amount that they're charging interest on or giving you interest on. You know? Initially, they paid you on $1,200. Now they're paying you on $1,260. So next time, what are they going to pay you on? Yeah, they'll give you interest based on this. This is how much you have now. So at the end of month 3, you would do the same thing. So put this here. You on Zoom? You put what 1205, 21 in here. Rate stays the same, time stays the same, 112. So let's go back to the original question. If you want to know how much money you have 2 years from now, and this is the only work you know how to do, what would you do? What would you have to do? Yeah.
A lot of math work to be that.
Yeah. So you have to do this over and over and over again, right? You know what I'm saying? So, okay, find out how much after month 3, and then find out how much after month 4, you know, all the way down to month 24, right? You'd have to do an additional, what, 22 computations? No, we're not going to do that. Right? So that's why there's a formula there next, right? But the formula exists because we don't want to do that. Right? If you want to look 10 years into the future on monthly payments or something, right? Just like yesterday with loans, you don't want to do that by hand or something, right? So anyway, what's happening here with compound interest is you somehow have to take into account that the amount of money you have is growing over time, and then you somehow have to be able to add that up over time. Which again, you could do by hand if you wanted to, but nobody wants to. There's a formula that takes care of it for you. Now, this formula is slightly more complicated than the simple interest formula because this process is more complicated, right? If you want to remember how much you have at each month stage, you got to somehow build that into the formula. So anyway, this is the compound interest formula. So the letters mean the same thing. So P is the initial amount, the principal, R is the interest rate as a decimal. I probably should have said. T is still time in years. So the letters all mean the same. The only new letter is this letter N, right here, lowercase n. You see it shows up a couple of times down there and then up there. That N is the number of times per year they pay you interest. So it's a per year value, okay? So just to make sure we understand different N values. In this previous problem, we were doing things monthly. So if N is the number of times per year you get an interest payment, what's N? 12, right? 12 times per year they cut you a check. What's another one? Quarterly is something that might come up in the homework. So quarterly means once a quarter, which is once every 3 months. So if you get an interest check once every 3 months, how many times per year they write you a check? 4. Right? And so on. I think that's all. I think the only other, well, there's this one, I guess, which we'll use in a second. Annually, right? So if they're going to cut you a check annually, how many times per year is that? Or yeah, how many times per year is that? Just one, right? No, so it's once every 3 months, but there are 12 months in the year.
Once every 3 months.
Yeah, right, yeah. So if it were every 4 months, yeah, it's kind of it swaps, right? Yeah. So I'm not sure if there's ever, if N is ever 3. I'm not sure because there's not really a word for that. Quarterly though means yeah. Okay, and then as before, you still have the final amount is the initial amount plus the total amount of interest. Now I should say that again, if you're rusty on math, which many of you are, that's fine. A formula like this can be hard to use up front. So I'm just going to show you the steps that most students use to use it when we have to use it. But as always, if you're more comfortable just skipping around, that's fine. So don't be intimidated by that formula. If you are intimidated by formulas, we'll use it a few times and you get the hang of it. Okay, so let's go back to example 2, which was what? I invested $1,200, 2.6% interest. I get monthly interest payments. And now I want to know how much money I have after 2 years. Okay, so what we have to do is use that compound interest formula to look out into the future 2 years to take into account all 24 payments. Okay, so again, some of you are comfortable with this and can just immediately do it. Others are not though. So for those of you who are not comfortable, let me just show you how to do something like this. So here's the formula just for reference. Okay, so first of all, it's worth pointing out, A here is what we're interested in, the amount we have in the future. So $1,200 turns into something. What does it turn into? Okay, so now we got to fill in the other letters. So P is 1,200. R is 0.026, just like it was in the example, divided by 12 for monthly. And then up here is 12 times 2 years. So when your homework or on an exam or something, if you see a question like this, I would write this down because this is most of the points. So lots of calculator stuff can go wrong from here. But if you have this written down, you at least know what you're doing. Okay, so now let me show you students who don't make mistakes with their calculator. Let me show you 2 things they do. Okay, notice 12 times 2 isn't an exponent here. It's raised to that power. Everybody see that? So when you ask your calculator for a number like this, it's very easy to, when you type it into a calculator, if you type it all at once, it's very easy to type it in such a way that 12 is up here, but then the 2 ends up being down here, which isn't what you want because that's not the formula. So the first thing I advise students to do is just figure out what this power is. So you can bust out a calculator if you want to, but I can do that in my head. That's 24. So again, you don't have to do what I'm saying here, but I'm just advising you that the students who are uncomfortable with this, but still do it correctly, these are the steps they take. So figure out what the exponent is first. Next, go to your favorite calculator and ask, what is this thing inside the parentheses? So my favorite calculator, again, is this. You have your own, either online or physical. So I just type in 1 plus 0.026 divided by 12. Now you have to be a little careful here in these problems, in WebAssign in particular. You got to keep a bunch of decimal points here. If you round too much, you're going to get an answer that is, but outside of WebAssign's parameters for what it'll accept. So I'm going to keep a bunch of decimal points or places. Like that. Anyway, all I'm saying is the stuff inside the parentheses, just ask the calculator what that is. So again, if you're comfortable just taking this expression here and putting it in a calculator, you can do that. That's fine. But some students aren't comfortable doing that. So if you want to get it right, exponent first, figure out what this is here. And now this, you can type into a calculator like so. You can say 1200 times 1.0021666667, whatever it was, to the 24th. Just like this times this raised to that power. And you get, if we round that, it's 1263.98. Oh, so when I typed it, I kept more. Yeah, no, that's fine. And so sometimes on WebAssign, by the way, if it counts you wrong, you may just have to go back and keep more information here. So again, if you round this to 1, you're going to get the wrong answer. If you round it to 1.002, it probably still might be wrong. So you just keep enough so that WebAssign. And again, if you're comfortable just doing this all in one step and not rounding, then you'll get the right answer. But again, some students aren't comfortable doing that. On an exam, of course, I don't care. I don't care if you put like a 7 here versus keeping that 7. But WebAssign, it can be particular about it. Okay, so any questions on using the formula in this problem? All right, so we're not quite Warren Buffett here, you know. So we started with $1,200. Our $1,200 over the course of 2 years got turned into $1,200, 63.98. So I don't know, we're not rich, yeah.
Why is N not 24? We're doing it over 2 years, not one.
Right, so you have to be consistent with what the letters mean. So basically, so some textbooks will just write like a capital N up here for 24 or something. You just have to be consistent. So basically, like the amount of money you have in the future depends on how many years it takes. So that's why there's a T there. But it also depends on how many times per year you get a check. Yeah. So, but to answer your question, some books will just cut to the chase and say write a 24 there up front. But your textbook writes it like this. So that's just what I'm doing.
So N is how many times per year?
Right.
Okay.
So this exponent in the end, this should equal the total number of interest payments you get, which is 24 in this case. Other questions on this work here? Okay, so yeah, so before you try this next exercise for a few minutes, let me just point out, in a problem like this, I could ask you how much total money you'll have in the future versus how much interest did you make. So in this case, this is the total amount of money you have, right? But this is not the amount of interest you made. You started with $1,200, whatever it was, right? That $1,200 made $63.98 in interest for you. So again, as always, the interest is the gap between that and that. So just keep that in mind. That's what this this equation here is saying. Okay, so take a few minutes to try exercise 1 if you haven't already. Quarterly, so you get a check every 3 months. And now we care about 3 years from now. How much interest did you earn? So as always, once you get an answer, feel free to show it to your neighbor if you want to, if you want. Confirmation check. So you doing okay, Caleb?
Yeah, I'm doing good.
Are you ready to talk about this one? All right, so I put the first couple of steps here. So I agree with what everybody did. Anybody have an issue with this? Let me again point out that mistakes you might make that have nothing to do with the concept of the problem lose you like a point or maybe no points depending on what it is. But for example, here, if you're like quarterly, well, yeah, quarterly is 3 times per year, right? Sort of what you suggested earlier. Suppose you did that. Does that really matter? I mean, no, it'll give you the wrong answer, of course, but conceptually that's not like a real error, right? So if you make little errors like that, it doesn't matter. But that's why you show me this kind of thing, right? So I see what you're thinking. I know you're thinking properly. And if you make a calculator mistake later, you're not going to get hammered for that, So if you, whatever, if you include an extra 0 here, because you read it from a calculator wrong, I'm not going to hammer you for that. You might lose a point, you might not, but a point at most is what you would lose. In the end here, what do we get? Probably not much more than 2,600.
$735.74.
So people got. Okay. So any questions so far on just using this formula here? Okay. Before finishing up by talking about inflation, I did want to point out that in your homework, where is it? Here we go. In your homework, you could be asked something like this. So we're going to sort of quickly work through this so we can get to inflation, but let's just think about the structure of this question, what this wants from you. So you're offered an interest rate of whatever, the account is compounded monthly, Time is 18 months and so on. But now they say 18 months from now, you want to have $3,000 in this account. How much should you invest? Okay, so before all of our work here, we knew what capital P was, we knew little r, little n, little t, and then we found capital A. Everybody see that? Okay, so now by contrast, what do we not know? And so in that question there, of these letters here, which letter do we not know? Sorry? So they do give you the interest rate. You're fine. Yeah, they don't tell you how much you would start with though, right? Yeah, so that's totally fine, Fern, especially up front. There's a lot of letters floating around, right? So it's like a language that takes some getting used to. Okay, yeah, so here they give you capital A, but don't give you capital P. Right? So now if we process what that's telling us and write it out. Okay, so again, if you're rusty on this sort of thing, that's totally fine. But let me write it out and then just show you again what you will do. So now I know that A is $3,000. Oh, this is right. So $3,000. I don't know what I start with. I have to find it. I know the interest rate is 0.032 compounded monthly. So N and N there. What is T in this problem? Yeah, you have to be careful as always, right? So if they give you months, you have to make it into years. So 18 months is 1.5 years. So again, if you write this down, if this were an exam question or homework question, this is most of the points right here. So again, lots of stuff can go wrong from here, but this is what you write down. So now there's basically just an extra step. So you should say to yourself, you should look at this and say, okay, this right here is just a number that I can find in my calculator if I take steps if I want to, right? And so what you'll end up with is number equals P times number. And then you're just back in like Friday or Wednesday of last week. If you ever have number equals thing I don't know times a number, you just divide over as the last step. So just an extra step here where once we find this number, we'll divide it over. Okay, so again, I'm going to do this in steps, which you don't have to do if you don't want to, but I'm going to do in steps just to show you. So first I'm going to ask a calculator, what is 12 times 1.5? Should be 18. I'm going to ask what is, 1 plus 0.032 divided by 12. And again, if you do this, you got to keep a bunch of decimal places so that you don't run afoul of Wolfram. Not Wolfram, WebAssign 0026. I'm just going to keep a bunch of sixes. So again, you don't have to do this, but this is sort of the way to minimize mistakes. So now I have 3,000 as P. I have that number raised to the 18th power. So I'll figure that out. 1.00266. How many sixes you keep, right? To the 18th power. And again, if you don't want to run afoul of WebAssign, you keep a bunch of decimal places. So there's no sort of rounding issues. The computer has some wiggle room in what it accepts, but if you're off by more than like a dime or something, sometimes it won't accept it. Okay, anyway, so you reach this step here where you have 3,000 equals P times number. So again, as a last step, you just take this number, divide over, like we did last week. If you do that, you get some number less than 3,000. Anybody have it?
2,859.58.
2,859.58, something like this. And so again, with WebAssign, you got to be careful to keep enough decimal places. For me on an exam, if you round this to like 267 here and round this to 491 here, that's fine. Your final answer will be off by maybe more than a dime. Doesn't matter. Still count as correct. But again, if you're doing WebAssign and you're like, man, I'm positive I'm doing this right, but it's not accepting, you may have just rounded too much if you're doing it in these steps. Okay, so anyway, what we've learned is that If you start with 2859.58, 18 months later, it will turn into $3,000 for you. If the interest rate is 3.2% and things are done monthly. Questions or comments on that? Okay, let's finish up by talking about inflation. Although I should say one more thing. Back with simple interest, those problems, I could give you A, P, and R and ask for T. Or I could give you T, A, and P and ask for R. I could ask for other letters. So far, I've asked you for capital A, I've asked you for capital P. I haven't asked you for little r or little t. Somebody see that? Like I could ask you, how long does it take to turn $1,000 into $1,500? You can imagine a question like that, right? Everybody see that? Now, I'm not going to ask you that. Why do you think that is? The answer is it requires too much algebra 2. Okay. So if you want to know what t is, for example, you have to know what a logarithm is. Now, at some point you probably knew or saw logarithms anyway, but it's not important now. So that's why we're not solving for other letters here, just capital A, capital P. Okay, so now let's finish up by talking about inflation. So many of you probably know what this is. You're grappling with it yourselves now, perhaps, right? So inflation just means that over time, costs of things go up. And it's of course particularly disturbing when it's like food, right? The cost of food goes up, which is happening now. But like car prices have been going up a lot recently, things like that. Home prices have been going up quite a bit, which on the one hand is good for me as a homeowner because my house is worth more. But I got my new property tax bill, which is based on your house worth, and man, that was a gut punch. Anyway. So currently, and I do mean like literally currently, the inflation rate stands around 7%. So the way inflation works is you think of it as a compound interest structure where you compound annually, it says here. So once per year, you think about compounding that interest when you're thinking about an inflation rate. Okay, so assuming this rate holds, suppose a TV costs $800 now. If that inflation rate of 7% holds, how much will that TV cost in 2 years, 3 years? And I should say, by the way, this most likely won't hold. So the Federal Reserve is raising rates now, which should help. But anyway, so that probably won't hold, but suppose it did. Okay, let me show you how to think about something like this. Basically, what's happening is you can think of all inflation problems as like an investment problem. So there's really no difference between these previous examples that we just did and inflation problems, except for the story you're telling. Okay, it's all the same. So you can think of this as an investment problem if you want to. So you say to yourself, okay, well, what if I invested $800 now? What would it be worth later? That's equivalent to this inflation story. That's how inflation is treated. So $800, 0.07, 7%. You compound annually. So what do you divide by here? Oh, I wrote it. One. That's nice, right? Divided by 1 is always nice. So you don't even have to divide here. So 0.07. And then up here you have n times t, but n is still 1 again. So that's nice. So times 2. So asking how much will that TV cost in 2 years is like asking if I invest $800 at 7% interest, how much will I have in 2 years? It's the same question. So here, since we've done it several times, I'm just going to cut to the chase and just grab it. So let me just ask the calculator for this all together. So $800, 1 plus 0.07 to the second power. Okay. So $915.92. Which, if you think about it, is kind of a big price increase, certainly relatively big, going from 800 to 900 bucks. So this is how you approach an inflation problem. So inflation, again, it works just like these investment problems. It's the exact same thing, just a different story. And then if you want to know 3 years, all you got to do is change this to a 3 in this case. So this price will be higher. I close my, yeah, 3. So now it raises all the way up to 980. So it's almost $1,000 in 3 years. So you can certainly see this kind of dynamic playing out recently. So in, oh, sorry, let me just pause and ask. Are there questions with either the pink or the black work here? Oh. Everybody okay with using that compound interest formula just for N is 1? Okay. So this kind of dynamic where, I mean, prices always go up some over time, at least for the last 100 years or so, because inflation has always existed over 0%. But in the spring of 2019, I needed a new car. So I told my wife, sorry, spring 2020. So I said, I need a new car. So I told my wife we should buy a new car. And she said, we're not driving anywhere because it's April 2020. And I said, that's a good point, but cars are super cheap right now. And anyway, we went back and forth and we decided not to buy a car. We decided to wait until summer of 2021 when car prices had risen by like 30% or something. So this kind of thing can happen to you where if you wait too long, I mean, if inflation is low, this isn't an issue, but going from $800 to $1,000 in 2 or 3 years, it's not trivial. So I think my car, I probably paid an extra $2,000 because I waited a year and a half. That's the way it goes sometimes. Okay. So now you guys think about these 3 to wrap this up. Let me just real quick say about this exercise 2. When you're using this formula, this A equals P stuff. Sometimes students have trouble knowing what A is and what P is. Okay, what means what? So in this problem, there's a $200,000 number right here. Right? So that means either A or P, because it's not interest rate, it's not time, so on, right? So the question is, what is it? And if you're confused, you should always ask yourself the following question or make the following observation. A always comes after P. Okay? P turns into A later. So there's some sort of time movement from P to A. So in this case, in this exercise, a lot of times students will initially say, oh, P is 200,000 because it says now, 200,000 now, present value, principal, whatever, right? Everybody see that? However, yeah, what was it worth 15 years ago? So what this question is saying is 15 years ago, I don't know what it was, but then over time, it turned into $200,000. Everybody see that? So in terms of the time process here, $200,000 comes later than what you don't know. Yeah, so you actually have an A here, it's $200,000. It's the later value. If you ever want to know the earlier value in any context, the earlier value is P, the later value is A. So you just always think about that time flow if you're wondering what a letter means. Okay, so I think maybe 10 minutes to think about these, and then we have time to do a couple on the board before we go. And then we'll be done with this section. So Caleb, how you doing? Good. How you doing?
Oh, good.
These examples make sense.
I think so.
Okay. Oh, yeah. If you do this enough, you get depressed, What do you think? Well, I appreciate you not trying to kill me today. No trip away. What do you think? Example makes sense. Yes. What do you think? So one thing you can always do, so if you're like, I don't know where to start, so there's a formula you have to use because it's an inflation problem. So you can just start trying to slot in numbers, sort of like maybe what gets you going, maybe eliminate the process of elimination your way to what you're supposed to do. So you say you don't know what to do with 15 years, but I mean, it is a time value, and that formula only has one time. Yeah. So this is a process that lasts 15 years, and there's only one spot where that could go.
makes sense.
Yeah, an inflation problem, that end is always more an inflation problem. It's always compounded annually. So that's almost like just imported for free.
Yeah. So the way you've written it here, that's 0.5%, so that's pretty small. Yeah, so this is, what you've written down is correct. So now I think you should back up and say, okay, P is what I want. What I'm staring at is number equals P times number. I just need that number one. Yeah, whatever this number is, it's 1.5 always. Yeah. You're what? Yeah, you're right. Sorry. I actually do it now. No. Yeah, I mean, sometimes it's hard to know when you're supposed to be done or not, but again, if you wrote this on your paper.
Yes, if you're, again, it's very easy to go straight here with the letters. So you're saying. Yeah, so in terms of time, right? It's 45 grand. Does it come before or later than? At this point? Right. So anytime it comes before, PO is comes before. Yeah. So basically in the future, as things get more expensive, you'll need more money to be able to purchase a thing. Not less money. Right. Yes. Okay. So this is right. This is 3 grand comes before. Yeah. Grab my- So you would do like, so like you have. Yes, what is 1 plus 5 to the 15th? You get your number you have there. Yeah. So now what you have to do is 200,000. I mean, as you have written, it looks like just you lost a factor of 100 or something. Let's just see 2.07, whatever. I'm sorry, I read that dot as a period, but it's actually, it's like, for you, it's like a comma or something, is that right?
Oh, I think that's, yeah, so I got this number. I don't know, I think I might have put something in.
Yeah. But you have this 2 something. Oh, I see. So you did 2,000 divided by, not 200,000.
Oh, okay, that makes sense.
So that was like your factor. You lost 2 zeros, basically.
Yeah, I didn't put it in the
Yeah, that's fine. That's why you write this and this. So I know you know what you're doing. And if I see this, I'm like, oh, you must have done something wrong on the calculator. That's not a conceptual error, you know.
Okay.
Yeah, so a house 15 years ago was worth less than half. Like it more than doubled in cost, yeah.
Mhm.
That's why he was depressed. Yeah.
Yeah.
I mean, it's only divided by the number.
Yeah, right, and it kind of, at the very least, it makes sense. So sometimes at the end of these problems, you can ask like, so for example, suppose that number were bigger than what you started with, that wouldn't make any sense, so you did something wrong. If that number was like a 0, you've done something
Yeah.
wrong. Yeah, that's right, the answer. After walking around, I'm just writing what I saw on people's papers. You okay? So here, this is like saying 20 years in the past, maybe, because this number has to always come before this one. Gotcha. If you look at the board there, 45,000 is now, 20 years later, what does it turn into on something? So you can always do this sort of gut check of like, if this number in the English, right, comes before or after the thing is applied, such words, slot. Yeah, so that's trying to think. You were finding, I think it was like 30 grand or something, right? Was your answer? All right.
Oh, I was.
So sorry. Okay. What do you think? Right, so this is a conversation I had with my father about Christmas. I paid $3 grand for digital piano in 1985. He told me that as I'm playing my digital piano, it costs $400, which is of course nicer than his if he bought it in 1985.
So you're right.
Mhm.
And so it's like. Okay,
Yeah.
I'm like, all right.
Yeah, it's like a fraction of a penny or something.
Yeah.
So we're running a little short on time. So just to make sure we finish up before 10:05. I think most people got through, at least through 2 and then some through 3. Let me just ask question 2, any issues with that equation? And I think everybody got the same answer after calculator issues, maybe it was something like 96,000 something, 203. So, you should have bought that house 15 years ago. Right? Okay, now here, this exercise 3, the issue was, where does this 45,000 go? And again, a very natural mistake to make is put it on this side, but then you got your time backwards or something, right? As we discussed individually. So anyway, this turns into something like 68,000, is that right?
66,000.
Or so, something like that. So that's with 2% inflation. Now, you can try slotting in that 7% inflation and see if you're happy with what comes out, you know, I mean, way bigger. Okay, now exercise 4, as I was telling Fern, I put this in because this was an actual conversation I had with my father-in-law at Christmas this year. So he's a pianist, and in 1985, digital pianos were like all new, you know? So he paid $3,000 for one. Now, my digital piano at my house, which is pretty nice, cost $500 like 2 years ago. See, so, but it's not just that he paid $3,000 versus my 500, right? That gap is big enough. He paid $3,000 in 1985, right? So in today's dollars, let's just see what that is. I know some of you guys really write down the equation. So I didn't point this out to him. He seemed depressed enough when he told me the original amount. But so you do what, 3,000, 1 plus, what was it, 4.5% or something?
Yeah.
And how many years has that been? 26, 27, I don't know, 30s. You 2022 minus 1985, I guess it's 37, is that right? I was born in 1984, so I guess I should know.
I just use 30 because I saw it.
Oh. Oh, yeah, I was just giving that for reference. Yeah, I see.
Oh.
Yeah. So somewhere I read that for the last 30 years. So I was saying you could just extrapolate. Anyway, so I can see either way, it's fine. I can see why you slot in the 30. Because I said that, right? Either way, it's fine though. Well, let's do 37. Just to get the actual time. This turns into a lot. Yeah, I couldn't find the average inflation rate for the last 37 years when I was looking online the other night. 1 plus. Oops. 5. Whoa, what is happening? Okay. 15,290. Right. You know. Anyway. So like a digital piano in the 1980s is now like, you know, you have a pretty nice used car. Back in 2019, this is a really nice used car, right? Nowadays, less nice used car. All right, so any questions on compound interest, what we covered today? Okay, let me give you your homework. Again, I encourage you to correct these. Oh, by the way, I should have said this up front. Another thing to keep in mind is on your exam, you can bring in a sheet of notes that you made front and back. On your sheet of notes, you can write whatever you want. Yeah. In particular, you can have sample problems on there. So if you've turned in a question and it eventually gets correct, right? It gets a 10 out of 10, you could like write that in your notes for reference, you know? So that's something else to keep in mind.
Yeah.
Again, sorry, this name I couldn't read. Does anybody recognize this?
Oh, that's mine.
Oh, is this Jack? Okay.
I have to.
Yeah, so I'll see you on whatever day. Oh, Monday. Have a good weekend. Caleb, I'll see you. I guess I have yours in here, right? Did you turn this in? Okay. Yeah, I'll give it to you on whatever day you come back.
All right, sounds good.
Hey, have a good weekend.
All right, you too, bye.